Hi, thanks for tuning in to What's New in Android Development Tools at Home Edition. I'm Jamal, a product manager on the Android Studio team. And also joining me today is Tor. Together, we'll walk you through a few updates on Android development tools. First up, I'll cover a quick update on the product roadmap, and then Tor will give us a demo of some of the latest features in action. And lastly, I'll wrap up with some additional feature updates. Okay, let's take a look at the roadmap. At Google I/O last year, we chatted with you about our deep investment into product quality in an initiative we called Project Marble. I'm excited to say we still spend a significant amount of our development time tracking and improving key quality metrics such as memory usage, freezes, and type-in latency. Each week, we compare the quality of each build using quality dashboards and then further diagnose problems based on the data. In addition to quality metrics, we have also ramped our bug triaging process. In the past, we have not been as diligent in triaging all the incoming issues as quickly as we should have. To this end, we have a team-wide effort in re-triaging over 1,500 old bugs and now have a better filtering process for new bugs. All right. Since Google I/O, we released Android Studio 3.6 during the Android Dev Summit event. This release included support for view binding, integrated Google Maps UI instead of the Android Emulator, a new leak detection tool, and an update to the user experience to the design tools. And then today, the beta launch show for Android 11. We are excited that we just launched Android Studio 4.0 into the stable release channel just a couple days ago, which features a new motion editor for creating animations, a live layout inspector to aid in debugging your app UI, a build analyzer which suggests pro tips to improve build speed, and includes a big update to the CPU profiler. We will show a few of these in action today. Additionally, we are excited to show you what we just made available in Android Studio 4.1 in the beta release channel today, and what we released in the early preview of Android Studio 4.2 in the Canary channel. With all these features that you will see today, I would like to emphasize that we are striking a balance of quality investment with creating a rich set of features to boost your productivity. We know that you rely on Android Studio day in and day out to make high-quality apps. And we want to strive to continue to make Android Studio the best IDE for app development. So to those who send us feedback and opt in to share quality metrics with us, thanks. It helps us make the right product changes that matter to you the most. Okay, before jumping into the demo, I want to highlight we also made an update to our brand. The brand update is a visual cue that Android Studio is a part of the opinionated suite of tools and APIs that make up modern Android development. So don't be surprised when your icons get this visual refresh. All right. On the demos, I'd like to introduce Tor to showcase some of the latest features in Android Studio.
Hi everyone, let's take a look at what we've been working on recently. So let's start by looking at systrace. This is a profiler which lets you analyze your app at the system level, for example, to figure out why your UI is lagging. So here I actually had two swipes. I swiped here and I swiped here, and the UI was stuttering in between. So I can swipe out a selection here to see a bit more about what's going on. So you can see here that we're actually displaying the VSync pulses. That's when the system is basically refreshing the display. And we're showing you the frame activity and there was nothing happening here. We're actually highlighting that in red to show you that you're dropping frames, so your UI is no longer updating smoothly. So if we want, we can actually take a look at what the CPUs are doing, but right now I'm interested in the threads. So we can see the render thread, and below that is our application main thread. And I'm going to swipe out a selection for the time period when the UI was lagging. When I've done that, I can press M to zoom in on just that area. And now you can start to see the individual trace event names. And when I click on, for example, this long inflate event, you can learn more details over in the summary panel on the right. We list all the events of that name sorted by duration, and you can also view the top-down, bottom-up, or flame chart listing of the stack trace for the event. The system automatically traces a lot for us without any work, but we can also go in and add these trace tags ourselves. So here you can see that I've added an additional trace section in my fragment where the freeze is happening. after recording another system trace, I can drill in and confirm that that particular code section is the code that is running when we're dropping frames. And now, if we look at the same region again, we can confirm that that particular code section is the code that is running when we're dropping frames. And from there, we can continue the analysis with the other profilers. And speaking of other profilers, I want to quickly also show you that in Studio 4.1, we've revamped our memory profiler. So the UI should be clearer and easier to work with now, and we've added support for native memory profiling as well. All right, so let's close the profilers, and next let's take a look at our support for Jetpack Compose. Here's a composable, which is the compose equivalent of a view or widget. This one is for a calculator button. When you make composables, you'll often also create previews for your widget, where you show your widget with some sample data. For example, we have different colors for different types of calculator buttons, so we can create another composable which populates our widget with sample data, and if we annotate it with @preview, then it shows up as a preview on the right. This makes it easier to visually tweak your composables. Not only is it faster than running, but you can show multiple previews to test your composables under different conditions. So now we can take our calculator button and compose them into a digit pad, and here we have a preview for that. And then we can create another composable for the calculator's LCD screen. And finally, we can assemble this into a calculator. As you can see, we put the LCD panel and digit pad into a column and turned that into a calculator composable. Right now, we're seeing a single preview for this calculator, but note that I can also repeat the preview annotation multiple times and override various aspects of the appearance, such as wide display or large fonts. And here I can then see those previews. And if I want to override something like the theme, I can just add another preview composable. So here I'm showing a preview of the calculator under a different theme than the default one. This is material theme. Let's jump into a different part of the app, and here we're building a shopping cart for a store. Let's say I'm trying to use this shopping cart item composable and I'm a little unsure how to configure it. Look what happens if I pull up the docs for this widget by Ctrl-J. Not only do I get documentation, but a whole example of how to use it and a rendering of what that looks like. So let me show you how easy that was to hook up. If we go into that composable, you can see that all we had to do was use Kotlin's kdoc tag @sample and then point to the preview composable. That composable is yet another preview like you've already seen. And the code here and the preview render results are both combined to create the docs automatically. Sometimes code snippets and documentation are not correct because they're not kept up to date, but that won't be the case here since your sample code is compiled at the same time as your app is. And if you change your APIs, you've got to update your sample code to match. Another useful purpose for the preview is to quickly navigate to the right code. If I want to look at the code for this plus button, I can just click on the button here in the preview. And once I do that, the editor selects the corresponding composable in the same file. As you can see, it's just selected a shopping cart item row. But if I double-click, I can dive all the way into the compose hierarchy, and now we can see the compose code which handles the graphics for the individual button. So single-click selects the closest composable in the same file, and double-click jumps to the exact composable that you clicked on. For previews, you can make a lot of copies of your preview setup to show the data in a number of ways, but that can be pretty repetitive. So we're also adding support for data sources where you can feed sample data into the preview. So take a look at this example. Here, our preview takes a parameter, in this case a color, and we marked it with a special annotation which points to this sample data provider where we simply return a bunch of strings. If you look at the previews, you can see that that's all we had to do. It iterates through all the data and adds a preview for each item. And we're going to provide a bunch of built-in sample data to make this simple. So for example, this is a sample text generator in the Compose tooling library which returns lorem ipsum sample text. Let's jump back to our calculator for a second. In some cases, you can even make your preview functional, not just visual. Notice that little finger icon above our preview? If I click on it, that will turn on live preview mode. Now we try to run parts of your app on the fly within the IDE. Let's see what happens with our calculator. So if I run some basic arithmetic like 3 times 8, it computes 24, which means that we've correctly hooked up our calculator compose code. And when I'm done, I'll press stop. So the preview is great for looking at your widgets under a number of scenarios and to even tweak some of the behavior, but of course, you'll want to really run your application as well. So let's do that. I'm going to hit run, So this will run our app on the emulator. As you can see, now in Studio 4.1, we have the emulator embedded within the IDE. And that makes it really easy to work with. I don't have to juggle application windows to find it, and I can assign a keyboard shortcut to hide and show it. So now it's installing the app. Notice, by the way, how quickly the emulator booted. That's because I'm using emulator snapshots, and we made this much easier to access now. So once I have the emulator in the state that I like it, I click on the Save Snapshot button here. I can name it. And notice how I can also designate this as the snapshot that I'll boot from next time I restart this virtual device. We've also added some basic options here for changing your boot options later. And I'll just go back to the one I configured before. A couple more tips for the emulator. First, when you resize this window, we scale the emulator to fill it. But if you want to zoom in further, we have zooming controls right here on the surface. And if you don't need this, or if it blocks your emulator, note that there's actually an option panel up here where you can hide the zoom controls. And you can also go ahead and crop the device frames if you want to get as much screen real estate as possible. But I happen to like the way the device frames look, and I have a large monitor, so I'll put that back. All right, so our app is up and running, and we have a simple store app here backed by a database. And the next feature I want to show you is our new database inspector. All I have to do is open it from the bottom left corner and wait a couple of seconds. Studio will start talking to the app process and discover the databases. So this is an app which is using the Android X Room library, so we can see our room database tables here. And I can double click on the shopping cart table to open it up. As you can see, we have one item in there with quantity 2. Let's take a look at what happens when I go over in my app and increase the quantity to 3 and 4. Nothing happens immediately, but I can now click refresh on the table, and now you can see the correctly updated quantity value. I don't even need to do this manually. Let's turn on live updates. And when I've done that, you can see that when I interact with the app, the table responds pretty much immediately. We can also push data in the other direction. So let me turn off live updates. And now I'm going to go in and edit the color value. So I'll change it to oh so orange. And look what happens once I change it. The product rendering in the shopping cart updates to match. So we can push data back into the apps as well on the fly. This is the corresponding source code. So you can see that it's using room, and we have some SQL code here annotated on some data classes. I can actually go ahead and run these SQL queries directly from the editor gutter. So now I basically ran the query to empty out the shopping cart, and so it emptied out. I can also run any SQL query that I want. So I can go and type in or copy paste in my SQL query, and when I run the statement, you can see that it inserts the data back into the database. If I run it again, we get the expected error because the ID is not unique. But if I create a unique ID, I can add multiple items into the database here. So that's the database inspector, which is available in Studio 4.1. Another feature we've added recently is improved support for machine learning model binding with TensorFlow Lite. So here's an app which performs object recognition. We made it really simple to wire up TensorFlow models. First, you get your TensorFlow Lite model file, for example, from tensorflow.org. And then in Studio, you go and open up new, other TensorFlow Lite model. In this panel, you point to your downloaded file. Now, I've already done that in my project with a downloaded object detection model. What Studio does is turn on model binding in your build.gradle file. You can see that here. Note, by the way, that this is a new thing we've added in 4.0. We now have a build features block where you can turn various features on or off if you don't need them. So for example, if you don't use build config fields, you can turn that off. There's no need to generate build config class when you're building. The second important thing the import wizard does is create a new source set called ML, and it places a copy of your imported TensorFlow Lite file in that source set. So if I click on this file to open, even though it's binary data, we have a special editor which shows the known metadata about this model. And it also shows you the code that you should write to process the model. So this is our running app over in the emulator. We're using Camera X and TensorFlow to run live detection of objects in the camera viewfinder. And while the emulator has a scene it presents to the camera, it's hard to get a feel for how that detection works. I want to aim my camera around in my room. So for that, we'll deploy to a real device. And a new feature we've added is Wi-Fi pairing. This is a new feature in Android 11, and we're still working on support for it in Android Studio, so this is a bit of a sneak peek. In our device chooser, where I normally select my emulator virtual devices, there's a pair with Wi-Fi option. So I invoke that, and there are a couple of options here, and one of them is to pair with a QR code. So now I'll show you what I do on my phone. I open up developer options, I turn on Wi-Fi debugging, and there's an option to pair by QR code. So then I just aim the phone at Studio, and after a few seconds, it should pair and establish a connection. And now I can use it as a device without a wire, so I'm going to hit just run. Here's the app. It deploys quickly over Wi-Fi, though if you have a good USB 3 cable, that's still going to be faster. But this is pretty convenient, especially because it doesn't take up any ports on my computer, and I've used all my ports to plug in some older phones to run tests on. And that's another feature I want to show you now, parallel device testing. So here's an app which has some instrumentation tests. Once again, we go to the device menu, but this time we're going to choose Modified Device Set. So here I'm offered all the devices that Studio knows about, my connected devices and available emulator virtual devices. What happens next is that once the binary is built, we push it to all the devices in parallel. And as soon as the app is installed on a given device, the test starts running there. And now you can see the results start to stream in. We display these results in a matrix such that it's easy to see what's going on and to drill into any failures. So here we have a test which is failing on some but not all devices. So I can click and examine the test results for each failure. Okay, let's cut that short and take a look at the visual design tools. So here I'm running last year's Google I/O app, and I'll open up the layout inspector. So just like with the database inspector, it'll automatically connect to the app and pull down the view hierarchy after a few seconds. So here you can see the whole view hierarchy, and this is updated live, like the database inspector, as I use the app in the emulator. I can also turn on a 3D view of my view hierarchy and drag the display around to get a sense of how the views all come together. And this also helps me debug overdraw. So here I can see that I have some views that are completely hidden by views on top, such as this green one, and that's unnecessary and we should get rid of it. Next, we can click on individual views, and when I do that, I can see it selected in the outline where it sits in the view hierarchy with parents and children and so on. And in the rendering, I can see the type of view I've selected. So let's say I wonder why this text is blue instead of black, which I attempted to make it. For that, we'll use the property sheet on the right. By the way, we recently added the ability to show you the dimensions in dips instead of pixels, but you can switch back to pixels if that's what you prefer in the Windows settings. So now I'm looking for a color. Instead of scrolling through all these, I can just search and then I quickly see it. Here's the great part. I can see that the color is blue and I can see my attempt to make the color black. We're showing here that there was a better match in the style lookup priority order. And I can drill into the exact resource resolution chain to see exactly where the color is coming from. So this brings some of the functionality of the Chrome DevTools to the Android view hierarchy. Next, let's take a look at the layout editor. One of the really nice things we have in the layout editor is support for tools attributes, which lets you override certain attributes while you're in the designer. So here, for example, in this layout, we're showing the navigation menu, but that means I can't see the content area below it. We've recently added this little button, a wrench icon, for temporarily turning off all the tools attributes. When I do that here, I can see the content pane below it. That works because we're turning off the tools attribute, which switches the drawer on. The second thing we've added is an ability to hide and show views conveniently right from the outline, like layers in graphics programs. That's what this second column is for. So for example, for this app bar, I can decide to hide it until runtime, either as invisible, where it takes up space, or gone, where it doesn't. I can also just do this for tools attributes. The third thing I want to show you is our support for accessibility validation, and this feature is still in development. So here's a layout where I've made a number of mistakes on purpose for accessibility. In the past, we've flagged some warnings we could tell by just looking at the XML, for example, failing to set a description on image tags. But now we're running the Android accessibility scanner on the rendered view hierarchy. That makes it possible to flag things that we can't determine just by static analysis. For example, it can flag whether there isn't enough contrast between the text and the background that it's painted on top of. Here's another app I'm working on. I'm going to build a photo carousel where I can drag through a number of images. We've recently added this transforms panel on the right, which makes it easy to visualize what's happening with the transforms. So for example, the image on the right and the image on the left are rotated slightly, and I can of course go and make some crazy edits myself. By the way, pro tip, if you double click on the slider, you can quickly reset it to 0. The next thing I'll do is migrate this layout from a constraint layout to motion layout in order to animate it. So I'll just right click and invoke convert to motion layout, and this also creates a scene file with 2 states, start and end. All I need to do now is to choose an image and the end state and change my scene to the way I want them to look. So I can, for example, go and add some rotation. And then I can play this transition. And you can see it's now playing through the animation by rotating the image. We've also recently added this transition editor so you can tweak the curves of your interpolators. There's a lot more functionality here, and just to show what's possible, let me jump to the completed state of this layout. So here you can see that we have created a number of different states and we've defined the transitions between them. And I can hit play in the design surface to view them, and I can go in and change the constraints, the transformations, and transitions. And if we run the app in the emulator, we can then verify that the touch handlers are working as expected as well. So here we've coordinated the exact motion as you drag from one image to the next. And I didn't have to write touch handlers or complicated code to coordinate the motion. I can keep tweaking that visually in the tools. For example, let's see what happens if I tweak this rotation of the next image. Let's invoke apply changes. Notice how fast that change made it to the running app. We made a number of improvements to our apply changes feature. There's special support in Android 11, both to have faster application installs during development, as well as allowing more structural changes to your app while running, such as adding methods and static fields. But you might still think that that build looked faster than you're used to. And if so, you'd be right. Because in addition to the improvements to Android 11 and our deployment pipeline, I've turned on 2 experimental Gradle features, native file watchers and Gradle instant execution. Let me invoke build again, Command F9. Notice how it finished immediately. That's because it now doesn't need to look at the file system to know that nothing has changed. You can see that in the output here. It's monitoring the file system with operating system support. And the second thing is that it's cached the whole task graph, so it doesn't need to compute anything. So if I go and change just one file and hit build, you can see that it gets very quickly to the point and it compiles the file. It doesn't run through a huge number of up-to-date checks. And Jamal will tell you more about this feature after my demo. Notice how at the end of the build we put a link to the build analyzer. That's to help bring awareness that we now have a feature to help figure out build bottlenecks. We've discovered that in many cases, the reason builds are slower than they need to be is because there are slow third-party plugins, or you have non-incremental annotation processors, and so on. So even if we were to make the Android Gradle plugin twice as fast, that won't meaningfully speed up your build if 80% of the time is spent in a different task. So every time you build in the IDE with AGP 4.0 or later, we collect some low overhead data to be able to analyze the build. So here's a more interesting project that I've built in advance. In Studio 4.1, we've reworked the UI significantly based on user feedback and testing. You can take a look at the tasks which are on the critical path because there's no point optimizing something which is running in parallel with a slower task. You're not going to make the overall build shorter. You can also break it down by plugins instead of by task. We also provide warnings for specific problems that we know about. So here we have tasks that are always run, even when the inputs don't change. That's obviously bad for incremental build times. Another problem that it's pinpointing is misconfiguring tasks such that they share an output folder, because if you do that, Gradle will not be able to run the tasks incrementally. And the last problem it's showing us is that when you're using annotation processors, you'll want to make sure that those are incremental. A lot of the most commonly used ones in Android are, but only if you've updated to recent versions. In short, if you're interested in making your builds faster, you'll definitely want to use the build analyzer to analyze your builds. And now let's do a quick lightning round of a few other features to look for. We've added editor support for dependency injection, both for Dagger and our new Android X HILT library, and this makes it easy to navigate between providers and receivers. We've also revamped our support for editing shrinking files with full error validation. So here, for example, I can see that I've forgotten to update my old rules after migrating to Android X. We also have support for core library desugaring. So when you turn that on, you can, for example, use java.time in your apps on older API levels that didn't include it. If you look at the bytecode, you can see that we've rewritten references to JavaTime with references to a locally bundled library. We have also added support for Kotlin Gradle script, not just in the editor, but across the IDE. If I, for example, open up the product structure dialog, then I get suggestions from my KTS project, and when I hit apply, we can sync the updated build model back to the build files correctly. And last but not least, we've rebased Android Studio 4.1 on top of IntelliJ IDEA 2020.1, which brings with it a huge number of new features across the entire IDE, as well as quality and performance improvements. Well, I think that's going to do it for my demo, so thank you for your time, and back to you, Jamal.
Wow, thanks, Tor. So that exciting demo hopefully highlights the end-to-end range of features that we are invested in to make you more productive, from designing, debugging, to performance profiling. Before we close, I want to highlight a few additional updates to the Android build system. In Android Studio 4.1, you can now try out Gradle configuration caching, a new file watcher, and a virtual file system for Gradle. These features combined provide a dramatic boost to your app builds. Of course, results can vary based on your particular project setup, but benchmarks on the Google Santa Tracker app that you can find on GitHub show almost a 60% decrease in incremental build time when you use these features together. Most of the work is done on the Android Gradle plugin side, but other build plugins also need updates before we can turn this on by default. So please try out this preview feature today and provide feedback. Lastly, for build, we are previewing new Android Gradle plugin APIs in Android Studio 4.1. Unlike previous versions, the new Android Gradle plugin APIs will have a clear separation between public API and internal implementation. Plus, we'll have an official documentation as well. The APIs are a work in progress, but we will add more over the next several releases. Secondly, the new APIs will be maintainable for future upgrades and internal system improvements without breaking your public integration points. Finally, it is dynamic and compatible with configuration caching by allowing you to move any computation, like version code, to tasks. All right, that was a lot, but the Android Studio team and I are excited to roll out this range of new features. The features that Tor and I showed you today can be found in either the latest stable version of Android Studio 4.0, while many of the Jetpack Compose features can be found on the Canary channel with Android Studio 4.2. Thanks for joining us today to hear the latest on Android development tools. If you want to try out the features you saw in Android Studio 4.1 or 4.2, you can download the latest previews of Android Studio, the top link shown. In parallel, you can also download the latest stable version of Android Studio as well. As long as you keep your app project on a stable Gradle plugin version, you can easily download and try out features in both the stable and Canary channels of Android Studio. Okay, on behalf of the Android Studio team, thanks again for watching, and please keep an eye out for more deep dive content about Android developer tools in the upcoming weeks ahead.